Okay, guys, so I'm so sorry for my graph. It looks really bad, but my writing, you guys know, is not the best. So I'm gonna just write here in the right. I'm gonna show you what I'm meaning with all the data in the whiteboard. So the vector one, guys, so I'm just gonna go back a little bit. So this is a problem where we have the Titan submarine, remember? And the Titan submarine is traveling, so this is my Titan submarine. Again, I'm so sorry, my drawings are crap. I'm not very good at drawing. But this is our submarine, right? And it's making a trajectory, is displacing from one point to another. And we have some information regarding the vectors of displacement for these submarine. So the first trajectory or the first displacement that the submarine does is of 40 kilometers, right, to the right, with an angle of 25 degrees. Then, after he gets to that point, he has to go upwards a little bit. And he does a second trajectory of 30 kilometers to the right with an angle of 40 degrees, right? And then, after he gets to that point and he has to wait for a little bit, he kind of still goes up, but he's not going as fast or as with a slope as big as the last one. So his third displacement is of 15 kilometers with an angle of 15 degrees, right? So that's the information we have for all these three vectors. And what the problem is asking me, what is the resulting vector of displacement for the submarine? So let's write it down as the vector for the submarine. What is it? We have to know that now. So that's going to be interesting, okay? So anyway, what we can do, guys, we can work with the components for the vectors, right? We're gonna try to figure out the components for each vector. So I don't have a laser here, but I'm just gonna draw a little bit on top of it. So we're gonna try to find the components for each vector using trigonometry, right? And then we're gonna add those up, okay? So let's start with vector 1, which is 40 kilometers and the angle is 25 degrees. Okay? So what we're going to do is we're going to use the formulas that we already kind of got or discovered from last video or the last class or whatever class we've been talking about. And we're going to use that the component in x is going to be equal to the length of the vector, right? Cosine of theta, of the angle. Okay? So in this case, we have that the length of the vector is 40 times cosine of 25. So that's going to give us the component in x. Now the component in y, though, we're going to be using the length of the vector sine of theta. So the component in y is going to be 40, which is the length of our vector. And then we're going to use the sine of 25 degrees. Okay? Okay, guys, so the component for x in this case is going to be 26.25. And then the component in y, so let's do the calculation real fast. So it's going to be the sine of 25 times 40. So that's going to be 16.90, right? So there we go. We have our components for our first vector. Now, I'm going to move this a little bit. You guys can pause this. I'm going to actually upload the whole Jamboard so you can look at it, right? And now we're going to start doing the same procedure, but now for vector number 2. So vector number 2 has a length of, I don't remember, so let me see, 30. So it has a length of 30 kilometers, and it has an angle of, I don't remember, 40 degrees, right? So we're going to use exact same procedure as we were doing in our vector number 1. And we're going to do that vector x is going to be equal to the length of vector 2 times the cosine of theta, and then vector y is going to be equal to the length of the second vector sine of theta. So I'm just going to stick to one way of writing this. So we're going to substitute, and let me just unblock my calc, otherwise it's going to take forever. We're going to substitute the data, so we have that the length of the vector is 30 times the cosine of 40 degrees, right? And then we have 30 sine of 40, right? Am I doing this right? So yeah, we're doing it right. So anyway, we calculate that on our calculator, and we get that the vector x, or the component in x, is 22.98. I'm sorry, that's my dog. And then we're going to do the sine of 40 times 30. So that's going to be 19.28. There we go. So the same thing happens, guys, with the vector number 3. I'm just going to pause it and do it and show you the final result, so I can show you the final procedure to add all the components for the vectors. Okay, guys, so this is the result for vector number 3, right? So as you guys can see, we have the information for those 3 vectors. So we have, the components for each of them. And the question, what we're asked to do, is to calculate the total displacement of the submarine. So I'm going to do like a little triangle of what we might expect. So we're going to kind of see what is the resulting vector that kind of follows the submarine. Okay, so I'm going to do it in yellow, so we know that that's what we're doing. So the vector submarine, guys, so the vector submarine is going to be divided into its components in x and its component in y. Okay, and now the component in x is going to be made up of all the components in x of vector 1, vector 2, and vector 3. Now, let's write that down. So the component in x, which is, so I'm going to kind of highlight them. So this is the vector x, 1x, vector 2x, and the component x, I'm so sorry, for vector 3. Okay, so we're going to add those ones up. So that's 36.25. So this is going to be 36.25 plus 22.98 plus 14.48. Okay, now we're going to do the same thing with the y's, and I'm going to, I think I should use like a code of color or something. So let's use green. Yeah, so I'm going to do by with green, okay? And we're going to add the components in y for our vectors.